Hello everyone. Welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Associate Campus Access exam. In this session today, you will understand few concepts related to Aruba wired and wireless solutions. Before I move on, let me introduce the 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we will be covering few topics such as connectivity, switching, wireless LAN, routing and troubleshooting from Aruba Certified Associate Campus Access exam objectives. Let me briefly go through each one of them. Under connectivity, topics related to networking architectures and technologies and how to deploy the network infrastructure are included. Then switching includes the basics of layer 2 and layer 3 technologies and how to apply them on campus architecture and its elements. Wireless LAN covers the fundamentals of RF attributes, wireless functions and their usage when deploying them on Aruba wireless LAN solutions. The knowledge related to basic routing topologies, functions and the deployment are covered under routing. Finally, troubleshooting describes the basic troubleshooting methodologies in wired and wireless networks. Okay, let's look at the sample question under connectivity. What is the ideal Aruba access switch for a cost-effective connection to 200 to 380 clients, printers and APs per distribution rack? Question says that switch should support more than 380 wired devices. In this case, to provide such number of port capacity, we need to stack multiple switches. Let's look at the answers one by one. This image shows the number of member switches that can be stacked for several Aruba CX switching models. So let's look at the option A, that is Aruba CX6300. It supports stacking of up to 10 members using VSF, Virtual Switching Framework technology. Maximum number of ports per switch would be 48, as there are 24 port models and 48 port models. Therefore, 6300 switch stack of 10 switches can support up to 480 ports. Option B is Aruba CX6200. This supports VSF stacking up to 8 members, which can give maximum of 384 ports with 48 port switches. That is not sufficient to terminate all the said devices, but that is more than 384 because almost wired clients are 380. Then you have to add printers and APs. So it's not sufficient. So option B is not correct. Option C is Aruba CX6400. This is a modular core switch and it's not cost effective. It is expensive than the other models here, though it can deliver port capacity more than 380. So since it is expensive, option C is not correct. Option D is Aruba CX6000. This does not support stacking, so it is not possible to provide more than 380 ports. So this is not correct. Therefore, the correct answer is option A, Aruba CX6300. Take a look at the next question under connectivity. Match the most cost-effective option for cabling each requirement. All lengths indicate total cable length including patch cables, service loops, etc. were used. Okay, there are 4 requirements, so need to match the suitable cable option. First requirement is 100 GB connection with a length of 10 feet between 2 switches in the data center. Let me show you the use case here. In a data center, the typical general use cases, now you have 2 top of rack switches in a single rack. typically they are stacked using could be 100G. So this is one of the use case. So these are stacking, maybe VSF or VSX. Most probably it should be VSX. And servers are uplink, dual uplink to these top of rack switches for the redundancy. So in this case, these are top of rack switches. So one use case, you have to use this 100G connectivity between these two switches for the stacking. Another use case, you have to uplink to the data center core switch. So assume this is core switch. Then you will have uplinks from the top of rack switches to the core switch. So those uplinks could be 100G. So these are typical use cases for 100G, but 100G transceivers are not available. So to cater this requirement, you have to use DAC cables, that is known as direct attached copper. So DAC cable is a thick copper cable but having transceivers fitted on both ends. So at the both ends you will have transceivers here and here. The transceivers could be 100 gig, 50 gig, 40 gig, 25 gig or 10 gig. And these DAC cables are available in lengths of 1 meter, 3 meter, 5 meter, 7 meter. So these are typical lengths because typically they are laid within the rack. So between switches or top of rack switches to the core. So they are very short distance cable. For this 100G use case, we have to use DAC cable. So now for this first requirement, we have to use direct attached copper cable. Let me write here DAC. Okay, we'll check the next requirement. 1GB connection with a length of 100 feet, that is 30 meters between an edge switch and a user desktop. Okay, this is a typical user access connection. You will have a user desktop and it is connected to the normal floor level access switch. So this connection, they are talking about this 1 gig connection. So there are two options. We have Cat6e, 6A and Cat5e. Both cables are supported, but we have to look at the cost. So if you consider the cost, Cat6A is expensive because it supports up to 10G. But 5E is supporting up to 1G and Cat5e is cheaper. And they can go up to 100 meters for 1G connections. So the correct option to provide this requirement is Cat5e because that is cheaper than Cat6. So I'll write here Cat5e. Okay, next requirement is 10GB connection with a length of 200 feet between the distribution switch in the main wiring closet and the edge switch in a remote wiring closet. Okay, it's like a typical distribution layer to access layer downlink. So assume these are two distribution layer switches and you have access layer switch. So typically access layer switches are uplink to this distribution layer. So these uplinks, these are the uplinks they are talking about in this requirement. So these uplinks can go maybe a few meters or few hundred meters, depends on the location of those switches. And in this case, they are saying it is 10 gig and 60 meter. So to provide 10 gig via copper, you cannot go up to 60 meters. You can go up to maybe 30 meters. So to go up to 60 meters using 10 gig, you have to use fiber. Now here there are two options, multi-mode fiber and single mode fiber. So, but single mode fiber is expensive because transceivers are expensive. So the cheaper option to cater this third requirement is multimode fiber. In multimode fiber for 1G, they can go up to 550 meters. For 10G, they can go up to 330 meters. Okay, last requirement, 1 GB connection with a length of 2 kilometer between two switches in different buildings. So definitely to cater long distances, that is more than, if it is 1 GB, then if that is more than 550 meters, then you have to go for single mode fiber. So since they are talking about 2 kilometer distance, this is straightforward. It is single mode fiber requirement. Okay, hope this is clear now. So now let's move on to the next question. Switching. You are configuring a network with a stacked pair of 6300 switches used for distribution and layer 3 services. You create a new VLAN for users that will be used on multiple access stacks of 6200 switches connected downstream of the distribution stack. You will be creating multiple VLAN subnets similar to this that will be utilized in multiple access stacks. What is the correct way to configure the routable interfaces for the subnet to be associated with this VLAN? Okay, to understand the scenario better, you look at the image here. Question describes a setup with CX6300 distribution switch stack where layer 3 services are provided. Other 6200 switches are uplink to this 6300 stack. Requirement is to create a switched virtual interface for a VLAN. Since the layer 3 services are provided at 6300 distribution stack, SVI has to be defined there. Required VLANs need to be tagged on uplink so that necessary access switch stacks can utilize that defined VLANs. Let's look at the answers. Option A, create an SVI in the subnet on the 6300M stack. Option A looks correct. Let's check others. Option B, create a physically routed interface in the subnet on the 6300M stack for each downstream switch. Option B is not correct because physically routed interfaces are not defined for SVIs. Option C, create an SVI in the subnet on each downstream switch. Downstream switches are access layer switches in which SVIs are not defined. So option C is wrong. Option D, create an SVI in the subnet on the 6300M stack and assign the management address of each downstream switch to stack to a different IP address in the same subnet. Option D is not correct because there is no requirement to define management IPs for downstream switches. So correct answer is option A. Let's look at the next question. Wireless LAN. Which Aruba technology provides load balancing across radio bands and AP radios? Option A, Aruba Central. Aruba Central is cloud management platform. It's not a technology that provides load balancing. So option A is not correct. Option B, Aruba Client Match. Yes, it provides load balancing and actually load balancing across APs on different channels, and client match uses information such as AP load, client capability, and signal strength to provide load balancing and steer the clients to best possible AP in order to provide better throughput. Actually, client match is Aruba's patented feature. It's a patent. They have obtained patents long time ago. Okay, so option C, Aruba ESP, Edge Services Platform. Actually, Aruba ESP is a solution model, not a technology that provides load balancing. So option C is not correct. Option D, It's also wrong because Aruba Airwave, it's a NMS. It's an on-prem network management system. So option D is wrong. So the correct answer is option B, Aruba Client Match. Okay, so let's look at the question from routing. When using the OSPF dynamic routing protocol on an Aruba CX switch, what must match on the neighboring devices to exchange routes? Okay, before going through the answers, let's look at the image and understand how the basic OSPF configuration is done. Switch 1 and switch 2 are connected to each other via Ethernet 1/1/1 and 1/1/2 respectively. OSPF routing process ID should not be same in both switches, as it is locally significant within the switch. It can be same or it cannot be same because it's locally significant. There's no dependency. But router ID is unique per switch, so it cannot be same in both switches. To have the OSPF adjacency between two switches, the connecting interfaces should be in same area. That means Ethernet 1/1/1, Ethernet 1/1/2 should be in same area. Loopback IP would be different in each switch as it should not be duplicate, so it should be unique per switch. OSPF passive configuration, actually it is used to stop the interfaces being participated in OSPF process. So it depends on the requirement on that switch and no need to be same in both switches. So the correct answer here is option C, OSPF area. That has to be same in both switches. Okay, we have reached the final question under troubleshooting. A network technician is testing a new SSID for a branch office. They are able to connect, get an IP address and resolve DNS names. However, they are not able to browse the internet. On the existing SSID at the branch, connectivity to the internet works as expected on the same VLAN as the new SSID. The wireless client should have received a new role to allow internet access. What should the network technician verify to ensure both SSIDs function in a similar way? Okay, let's look at the option A. Verify the new SSID in broadcasting on all the APs at the branch office. Actually, client is already getting the IP and connected and client is able to resolve the DNS names. So it's obvious that SSID is broadcasting. So no need to verify that. So option A is wrong. Option B, verify that the implicit deny all is the last entry in the firewall policies. Actually, implicit deny, this deny all entry will block the traffic. Actually, it should not be there as the last entry. So we have to verify that it should not be there. So B is wrong. So option C, verify the firewall policies assigned, making sure the rules are correct and ordered properly. So that is, it looks correct because this is the general task somebody will verify to check the firewall policy enforcement. So let's look at the option D also. Verify each SSID's authentication and encryption parameters are enabled and the same. Since client is able to connect and get the IP, so authentication and encryption parameters should be correct. So they are enabled and it's working fine. So there's nothing wrong with that. So option D is wrong. So the correct answer here is option C. That concludes our training for today. I hope you found this overview of ACA Campus Access exam topics helpful. We have discussed sample questions covering the areas such as connectivity, switching, wireless LAN, routing, and troubleshooting. Be sure to check out 591lab.com for more online courses, practice exams, and training materials to continue your certification preparation. You can also visit www.591cert.com to learn more about our full suite of services. If you have any questions or concerns, please don't hesitate to contact us. Thanks for joining today's class, and I wish you the best of luck on your certification journey. Have a great day.